First thing you want to do is make a pitcher like this of salt water. If you're using a coffee cup can like this, size about, you're probably going to need the whole thing. You got to use sea salt because normal salts won't dissolve in water as well as sea salt or as quickly. So you take some water, mix some salt with it, and make sure, taste it, make sure it's salty enough, and it has to be completely dissolved as well. Alright, so this is my machine, the electrolysis machine. When you have it all running, theoretically hydrogen should come out of the red pipe, and oxygen should come out of the blue pipe. So this machine demonstrates electrolysis, which is the separating of water molecules, H2O, into hydrogen and oxygen gas. This is my garage. So I just made this out of a coffee can like this, and some screws, some holes, and metal and things like that you can find in a garage such as this. You also have salt water. Oh, and these are PVC pipes with paint, and I painted this, and then I just glued this cup on the bottom for a stand. So this is a very redneck attempt at a scientific experiment. Rah. Alright, so this is the electrolysis main container. These are the two contacts in here. They're just screws. So tip it over. So what you do is hook up. I'm going to use this battery charger. It's 12 volts and 1.5 amp. You could also use like a car battery, but this is easier, and you can find it more in garages. So you hook on the clips to the terminals, and then the electricity runs up into the screws. And I use screws because they're long like this, and they have the threads in it which give it good surface area for bubbles to form. And then here's my salt water. Okay, now I've hooked on the clips here. Positive, negative. Positive will yield a little bit of oxygen, and the negative will give you your hydrogen. The terminal, it'll come out as that one in the inside. Okay, so with this particular battery charger is 1.5 amps, and it has a selector for 6 and 12 volt. I'm going to put it on 12. You just hook up the clips, and then as soon as you plug it in, it'll go. So I'm going to fill this up with water. On some chargers, there'll be like an amperage selector. You can experiment with that. 1.5 seemed to work very well for me. Okay, I filled it with water, salt water, and always before you plug in the clips, or before you put the clips on the terminals, don't plug it in until you're all ready to go, because there's no switch. So here we go. Plug this in the right way. Plug it in. And you'll start to see hydrogen forming. All of that is hydrogen. And the oxygen one, for whatever reason, doesn't work as well, or at all in this case. I guess because the electrons are only flowing from the negative, and maybe it's not creating a good enough circuit. However, hydrogen is what you want, and it's getting very large amounts of it. Notice this is the negative side. And I have a way of separating it. I just have these pipes that you put on over the contact. Just like that. And then usually I put this cap on to hold it in place right here. However, I've found that large amounts of hydrogen in an enclosed space is probably not safe because of explosive hazard. However, this is your hydrogen, and as you'll run it for a few minutes, you'll notice that it turns very dark green, and I'm going to film it until that happens. And I'm not entirely sure what the water turns into, but I'm assuming it's some sort of dangerous acid, probably. You'll notice that this is fogging up. I wouldn't suggest either putting any hands in here, because 12 volts of electricity is running through the water. Now you've noticed it turned very dark. And my battery charger should change from the charging mode to charged, like this light here, in a second, because that's what happened last time. Yeah, so this looks very dangerous. Obviously don't drink it, but all those bubbles and smoke, or whatever you want to call it, in there is hydrogen. So there you go. Now go make a bomb or something. No, I'm kidding, don't do it. It's illegal.